Hello everyone, my name is Joel Dunai and this is my official unofficial network state exam solution. So it's now the 23rd topic, which is about Ethernet switches. This is quite easy. The purpose and the advantages of LAN segmentation with bridges. So of course the purpose and advantage of LAN segmentation is quite easy, that I come up with the exact example in my previous videos. That imagine a network where 100 units or computers hosts are connecting to the network. That what will happen, for example, they will share the same bandwidth. If there will be traffic, then they can slow down the network performance. And it is not that secure because, for example, if a broadcast message is sent out, then it will be received by all the hosts, for example, by the 100 devices. Then they have to use CPU because they have to process it. For example, even though only one will reply back to that, all the others have to answer. All the other will have to process that. And of course, as I said, this will also decrease the security of it. So of course the purpose is to avoid or increase the security. For example, we can put them into different segments. So for example, there will be 10 hosts or n devices in each. So the broadcast, for example, will be only processed by that 10 or 9 devices if one will send out something, for example. So of course it will increase the network performance, and the segmentations will help. The LAN segmentation with bridges, honestly, I don't know what to say about this. Bridges were used before switches, and bridges are slower than switches, and I don't know their actual functionality. I mean, how they are helping us, so I'm going to skip it. The LAN segmentation with switches, because we know that how does it look like. I've spoken it several times, I believe, or if not, then of course we have what the broadcast domain means. That simply imagine two hosts. There are two hosts, and imagine that they are starting to communicating. For example, this will send traffic to this will send traffic to this. So what's going to happen? Of course, collision, because that's called a collision domain. That's called the collision domain as a whole. So if they are going to speak simultaneously, or why the channel is not clear, then there will be collision. So what's going to happen? Imagine that we are putting this end device to here, and we are putting a switch here because we are talking now about layer 2. If this end device will speak to this one, to the switch, and the other will speak to the switch, then there will be no collision, because switches are creating different collision domains. So now this will be a collision domain, then this will be a collision domain. So now we have two collision domains, and this hole is called as a broadcast domain. So basically switches are helping to separate the network to several collision domains, a single collision domain. So that's the connection between switches and the broadcast domain. The collision domain. Okay, so the difference between the bridges and switches, as I said, the switches are much faster. The operation of switches is quite easy. I believe I have spoken about this in previous videos, that imagine a network where a new switch will be installed or implemented. Then in that case the switch will be connected to the network, and don't forget that the switch will work immediately. So it is good because it will set up itself immediately and can work. So what's going to happen? By default, we are at the layer 2, we are not at the layer 3, so these switches don't have routing tables like the layer 3 routers, so they don't know how to forward traffic. Here they have a MAC or CAM table in which they will store frames. And within frames, I mean, if a frame will be received on a port of the switch, then it will save the frame and the frame address, so the physical address, and the port on which it has been received. So by default, the MAC table is empty. It will receive any frame right now and will save its data in the MAC table or CAM table, and will broadcast out on all available ports of it, only on except on the one that the traffic came in. So it will send out. So for example, when the next traffic will come in and we'll see, now I'm going to visualize it to see it. So imagine that we have this switch here and it has a MAC table. By default is empty. A traffic will go in, it will save its port on which it came in. This will be the port and this will be the MAC address. And imagine that next time, so it will broadcast out on all its available ports, and imagine that next time it will receive a frame, and the frame, so again it will save the new frames port on which came in, will save its MAC address, and will realize that the frame is actually searching for this destination. Therefore it will just simply send out a unicast to the destination. So basically that's all. If the frame knows a destination by the MAC table, then it will send out a unicast message. If not, then it will send out a broadcast message. And basically I spoke about how the switches are learning what the MAC table. It is important that the MAC table stores only its content for 5 minutes, I mean one entry for 5 minutes, because it has of course a finite amount of resources. And if imagine that on this port again traffic will come in, it will simply update the actual one. I mean not update, it will update because it has a timer. It will update the timer to, I believe, store it for again 5 more minutes. So that's the actual workage of a switch. So let me see what we have covered. Features and operation of multi-layer switches, advantage, okay. MAC table, learning process of switches, I spoke about it. Symmetric and asymmetric switching, it is quite easy. That what does it mean? Imagine that here is this switch and it has of course a lot of ports, and the symmetric means that it has this port and this port. I'm going to visualize like this port and this port and this port and this port. So it simply means, symmetric means that the switch will share, I mean not share, will provide or support the exact same bandwidth on all its ports. So for example, on all its ports it's 1 gigabit per second on the bandwidth. And of course asymmetric is the opposite. The asymmetric means that it's not all the ports having the same, but there can be ports that are having a higher, for example, because for example, imagine that this with red is the others are supported by 1 gigabit and this has 10 gigabit per bandwidth. So what does it mean? It's quite easy. That imagine this is a server. So of course, in order to provide a more reliable or a reliable channel for a server to which more users will connect, the bandwidth should be higher than for a normal end device, for example. So this is just a quite simple example. Okay, so the multi-layer switches, I spoken about this several times, if I remember well. But we have the access layer, we have the distribution layer, and we have the core layer. At the access layer we are talking about hosts and switches. small switches. At the distribution layer we are talking about routing, and here we are having multi-layer switches as well, because multi-layer switches means, so by default the switch is at layer 2, and the multi-layer switches means that it has functionality, it has layer 3 functionalities, like it can do routing approaches like the routers at the layer 3. So that's why we are having multi-layer switches. That's their advantage, and honestly I don't know what's their disadvantage. Maybe they are more expensive, or I don't know what can be. But although I believe if we have routers, I believe they are somewhat better, but I don't know. Yeah, it's quite important that the multi-layer switch is much faster than a layer 2 switch. That's quite important. Okay, now we fulfilled so far everything. The comparison of the fast switching and store and forward switching methods. So switches are having or using two switching methods, and I believe this store and forward is the better or reliable, because the store and forward means that the switch will receive, the switch will wait until the whole frame has been received and will only send out the frame when it has been received. Therefore, if I remember well, it does some error detection as well there, or something like that. So therefore it will be higher the probability that it will send out a complete frame, which will not be a corrupted frame, to the next device or to the destination. So this is the simple approach, that it stores its frame until it stores its data until the whole frame has not been received, and then will send out. And if I remember well, this does buffering as well. Like if we receive data on a 100 megabit link and we would like to send out on a 1 gigabit bandwidth link, then it will it will do the buffering and send out. And of course, on the other side, we have the fast switching, which in reality is called cut-through switching. And that simply means that it does not has to wait until the entire or the whole frame will be received. It will, as soon as possible, receive a tiny chunk of a frame. It will send out immediately to the destination. Of course, it is more faster, because in this case it will send out everything as soon as it receives. But in this case, of course, the probability of sending corrupted frames are also increased as well. And that's all I know about these switching methods. Configuration of switches, I believe I don't have to talk about this. You can do a lot of stuff, and you can check about the configuration, like name and other stuff. That's easy. Management of MAC table, I spoke about the MAC table. Configuration of static MAC addresses for security. It's quite important that I come up with the example that, nope, my mouse died. So I came up with the example that we have the switch, and it will receive something, and it will save its the data, the sufficient data into its MAC table. So what's going to happen? Of course, we can do an attack like sending multiple frames on the same port. Therefore, it will be updated, or we are providing always fake MAC addresses in this. Therefore, the MAC table will always save the one which actually with new MAC addresses, so it will run out of the resources, the MAC or CAM table. Therefore the switch will not be available, and I believe if it's not available it will drop the traffic. So in this case we can use port security, because we can ensure that on this port only one MAC address can be passed. So this can be statically set, because static means that we are giving only one. It will be a one-to-one relationship. So we can do that. For example, this port, or this will be a port security here. That simply means that if an invalid frame will come that will have a different physical MAC address, then for example the port will shut down or something will happen, or yeah, that's basically port security, and that's the MAC address security, because we have to define that only those, that's the best use case, that only define those traffic, I mean those physical addresses that will be good, that will, the frames that will be good on that switch. Okay, so basically that's all about this topic. I believe I covered everything. And again, if I said something wrong, then I don't really care. And don't forget to subscribe.